Assalamu alaikum. This is the third part and the third question of the May June 2024 paper 1 variant 1. In the recent two parts we had discussed two questions. The first question was from roots of polynomial equations and the second question was from proof by induction. And this third question is from summation of series. Okay. So the question is saying use standard results from the list of formula to show that. First of all we will discuss that what list of formula MF19 gives us. The list of formula MF19 gives the two formulas. The first formula is for sum of r square till n and r equal to 1 is equal to 1 upon 6 n plus 1 2n plus 1. And it also gives one more formula, sum of r cube and r equal to 1 upon 4 n square n plus 1 whole square. Okay, these two formulas are given while we have to memorize one more formula. We have to memorize that sum of n r equal to 1 and r equal to 1 upon 2 n plus 1. These two formulas are given in MF19 while this formula we have to memorize. Okay. So now the question is saying that we have to prove this is equal to this. How we will do this? First of all, we will expand this. We will just expand this. r plus 1 by 3. Wait for a bit, let me shift it to the second line. r plus 1 by 3r plus 4. We will expand this. First of all, we will just multiply this bracket. Okay, so it become r square plus r, and we will copy out the third bracket as the second bracket, 3r plus 4. So this is equal to this. Now we will multiply and expand this. The r square will get multiplied by this and then get multiplied by this. So it becomes 3r cube plus 4r square. And then we multiply this and this. It becomes 3r square plus 4r. Now we will simplify this and it becomes 3r cube plus 4r square plus 3r square becomes 7r square and plus 4r. We had expanded this. We can write that sum of r plus 1 by 3r plus 4 till the limits of capital N and r equal to 1 here is equal to sum of capital N r equal to 1, and in bracket we will write 3r cube plus 7r square plus 4r. We can also write this same as sum of n r equal to 1 3r cube plus sum of n capital N r equal to 1 7r square plus sum of 4r with upper limit n and starting from r equal to 1. We can also write this as 3 sum of n are equal to 1 and r cube here, plus we can write 7 sum of n are equal to 1 r square, plus 4 sum of n are equal to 1 and r. We know this, it is given in MF19. We know this, it is also given in MF19, and we have to memorize this. Okay, now we will write 3 multiplied by sum of r cube is equal to this 1 upon 4 capital N square n plus 1 whole square. Okay, then we will write plus 7 multiply by sum of r square. This is also given here 1 upon 6 n plus 1 2n plus 1 and we will write this also plus 4 by, we have to memorize this, which is 1 upon 2 and n plus 1. You have to be careful and you go along with the capital N because the question is using capital N. Now what we have to do? What was our target? Now we have to go for our target. Our target is 1 upon 12 and n plus 1. We can get this easily. We will write 1 upon 12 here as a common. We are taking 1 upon 12 common. Currently we are not getting how we got 1 upon 12, but still I am telling you, if we want an integer in common, you can take it. I will tell then how we will balance it. Then we want n. We can see there is n square, there is n, and there is also n. So we can take n common. And we also require n plus 1, which is n plus 1 whole square, n plus 1 and n plus 1. So we can write n plus 1 here. Further ahead, it also requires n plus 2. We don't have n plus 2. So now what we will do? Yeah, so the point is, now we will write this here after taking common this. Okay, so 1 upon 12 is taken common. 1 upon 12 multiplied by x is equal to 3 upon 4. As we want 3 upon 4 should be, as 3 upon 4 is here, which number will get multiplied to be equal to 3 upon 4? So we will multiply, so it will be x is equal to, the 12 will go there and multiply by 8, so it become 9. So here it becomes 9. This is n square and 1 n was taken common, so we will write n here, and this is n plus 1 whole square and 1 n plus 1 is taken as common, so we will write n plus 1 here. Okay till this? I hope you are okay till this. Then plus, we have 7 upon 6 here. What we will multiply with 1 upon 12? 1 upon 12 multiply by something to get 7 upon 6. Now we will do 7 upon 6 multiply by 12, which is equal to 14. So x is equal to 14. Now we will write 14, and this n was taken as common, this n plus 1 was taken as common, So we will write this 2n plus 1. Okay. Then we have this 4 upon 2. And the same question is here, that 1 upon 12 will multiplied with x to get 4 upon 2. 4 upon 2 is basically 2. Then we will take 12 to the right side and it will get multiplied. So the x will become 24. If we will multiply 1 upon 12 by 24, it becomes 2. And 4 upon 2 is also equal to 2. So we will write 24. And n plus 1 was there, which was taken common. So yeah, here our bracket get closed. I hope okay till this. What we did till this, let me give you a quick review. Okay. First we expanded this bracket and we got our expansion. Then we write like this, our expansion, and then we separated like this. Then we inserted the given, this was given MF19, this was given an MF19, and this we have to memorize. We inserted it and then it's algebra. Okay. Then we have to take 1 upon 12 common. So we will write 1 upon 12 outside and we have to take n common. So we can see that n is in all three terms. Then we have to take n plus 1 common. Again we can see that n plus 1 is in all terms. We take n and n plus 1 as a common easily. The point is we had 1 upon 12 outside, which we can't see it is common in all three terms. So how we will compensate it? As we took 1 upon 12 common, we will multiply 1 upon 12 with a number that will give us 3 upon 4. If we multiply 1 upon 12 with 9, it will give us 3 upon 4. Then we have to get a number which will get multiplied to 1 upon 12, so it will give 7 upon 6. So if you multiply 1 upon 12 with 14, it will give 7 upon 6. Then we want a number. There is 4 upon 2. We want a number. 4 upon 2 is basically equal to 2. We want a number that will get multiplied with 1 upon 12 and it will give us 2. So the 24 upon 12 gives us 2. So that's why we write 24 there. I hope you get it till this. If not, you can ask me in comment section. I know the working in this is untidy, so you can get a clean and neat work through the link in the description, and you can also get the clean and neat working through maybe it is also copied on the comment section. You can get the link through there also, where you can find the past papers, solved past papers. Okay, so let's move ahead. We are still not on our target. We want n plus 2 and 9n plus 19. Okay, so we will write 1 upon 12 and n plus 1. We will not change it. This bracket matters a lot. We will multiply this, it become 9n square, and then we multiply it with this and it become plus 9n. Then we multiply this, it become 28n. Then we multiply this, it become 14, and the 24 remains as it is and the bracket get closed. Then we will do 1 upon 12 and n plus 1. This becomes a quadratic equation. 9n square will be copied as it is. Then 9n plus 28n get added, it becomes 37n, and the 14 plus 24 will become 38. Now we can solve the quadratic equation using the calculator. Before that, let me copy it down it. Yeah. So 9n square plus 37n plus 38. We will get two factors n plus 2 and 9n plus 19. Now let's match up with the question what we have to show. It was 1 upon 12 and n plus 1 got it, n plus 2 got it, and 9n plus 19. Yeah, so we are our one answer. So this is shown. Wait, if I can show you the solved working with a clean and neat and tidy, so I will show you. So if it gets open, no, it is not getting open. I will show it later. Up till that, we are going to do part B. Okay, let me show you how you can access that. You can access that through YouTube. Let me show. If I close this, the YouTube gets open. Oh no, sorry, my Wi-Fi is not working yet, so that's why. So what we were doing, express 3r plus 4. This is the second part of the question. Express 3r plus 4 r plus 1 in partial fractions, and hence use the method of differences to find this. Okay, our first target is to do partial fractions. So this is 3r plus 4 upon r plus 1. We have to do partial fraction. We will write it as the denominator is linear, so we will write it as a upon r plus b upon r plus 1. Okay, now we will do this 3r plus 4 upon r plus 1 is equal to a by r plus 1 plus b by r. We just cross multiplied upon r plus 1. Okay, if we can see that this and this got cancelled, so it becomes 3r plus 4 is equal to ar plus 1 plus br. Okay, I think it is better to write it in the next line instead of writing to there. Yeah, now we'll consider this, and we will do the first denominator as r equal to 0. Then we will do this r plus 1 equal to 0, and we will get the second r as negative 1. We will use these two r values. First we will do r equal to 0, and 3 by 0 becomes 0 plus 4 is equal to a 0 plus 1 will be 1, so a is equal to 4. Okay, then we will find out b. For b we will use r is equal to negative 1. We will write 3 negative 1 plus 4, and if we write negative 1 here, negative 1 plus 1 becomes 0, and a multiplied by 0 becomes 0, so we will directly write b by negative 1, and it become negative 3 plus 4 become 1, and this is negative b, so the b becomes negative 1. Okay, So we got our partial fraction here. Let me move it above for getting space. Wait. That will be okay. Not such problem. We will write 3r plus 4 r plus 1 is equal to 4 upon r minus 1 upon r plus 1. Okay. Now there is still a lot of working and we will solve it. Now we have to use that answer and do this using the method of differences. Okay. Here the point to be noted that we had got partial fraction for this. That partial fraction is getting multiplied by this. Okay. So we will do sum of capital N is used. Let me confirm it. Yes, capital N is used. And r equal to 1. We will write 3r plus 4 r plus 1, then 1 upon 4 r plus 1, okay, is equal to sum of n r equal to 1. What we get as a partial fraction? 4 upon r minus 1 upon r plus 1 bracket close, and it is getting multiplied by 1 upon 4 r plus 1. As we have two brackets, so we can't do the method of differences. To do method of differences, we want just more than one terms. So now what we will do? We will do that is equal to sum of n r equal to 1 multiplied with this, then multiplied with this. It becomes 4 upon r by 1 upon 4 r plus 1 minus 1 upon r plus 1 1 upon 4 r plus 1. Now we can do method of differences. To do method of differences, I want plenty of space, and here is plenty of lack of space, so I can't do here. So I will copy this, wait for a bit. This is question 3 part B, okay, and I am doing here. Question 3 part B. Those who will look for neat and tidy work, which you can get through the link in description, you will get the link for a drive where the solved past papers will be uploaded, so you can access the complete solved May June 2024 paper on variant 1 through that link. And on that there will also be lack of space, but that lack of space has been covered on the page number 16. Let me show. Page number 16 is a blank page, additional page, where the remaining solution has been solved for this question 3 part B, okay. Now we are doing here, because while recording I just want extra page to show how the question will solve, because at this time I'm not just solving, I'm main target is to explain. To look the solution, you can go to that drive. First of all, we will insert r equal to 1, so it will be 4 upon 1 1 upon 4, and r plus 1 become 2, then minus 1 upon r plus 1 become 2, because we are taking r as 1, then 1 upon 4 r plus 1 becomes 2 here. Why we are taking 1? Because here is r is equal to 1 as the first value, okay? And then now we will take r is equal to 2 and I will write 4 upon 2, 1 upon 4, 3 minus 1 upon 2, 1 upon, sorry, not 1 upon 2, this is 1 upon 3, 1 upon 4, this is also 3. Now we took r is equal to 2. Now we will take r is equal to 3. We have 4 upon 3, 1 upon 4, it becomes 4 minus 1 upon 4, 1 upon 4 power 4. And let me write it in the n form. I will write it as 4 upon n, capital N, 1 upon 4 n plus 1 minus 1 upon n plus 1. Allah! Wait for a bit. And there will be 1 upon 4 n plus 1. Okay. If you calculate this through calculator, you will get as 1 upon 4. Okay. This is equal to 1 upon 4. This is equal to 1 upon 32. And this is also equal to 1 upon 32. Okay. So this is minus 1 upon 32 and this is plus 1 upon 32. So they both get cancelled. Then we calculate this through calculator. We got 1 upon 192. Then we calculate this from calculator. It also become 1 upon 192. This is negative 1 upon 192 and this is positive 1 upon 192. So they both get cancelled. We got a pattern that it is slicing over like this. We got a pattern. As the 2 got cancelled, so this will get cancelled like this. Okay. So the remaining terms are this. This is remaining term. And this is remaining term. Okay. Now I will write is equal to. If we do this from calculator, it is equal to 1 upon 4. And we will copy down the second term minus 1 upon n plus 1, 1 upon 4 power capital N plus 1. So this is our answer. I hope you get this. I can write here our answer 1 upon 4 minus 1 upon, wait for a bit, wait, yeah, there is not a 4, there is minus 1 upon n plus 1 and here is 1 upon 4 power n plus 1. This is our answer. I hope you got it. What we do? First we do partial fraction. As our denominator is linear, both are linear. Like this is linear, this is linear. We consider like separate, different. Okay. So our form will be like this: a upon r plus b upon r plus 1. Then we solved it and we got a simplified equation. Then we do r is equal to 0 and then r plus 1 is equal to 0. Through r equal to 0 we got r equal to 0 and through r plus 1 equal to 0 we got r is equal to negative 1. We inserted both r is equal to 0 and r is equal to negative 1 and we got a is equal to 4 and b is equal to negative 1. Then our partial fraction is completed here. Then we did method of differences. We just write like this and multiplied it to get two terms. Then we got these two terms, so it will be helpful to cancel them. Then we inserted 1 instead of r. That means here the r is equal to 1, here the r is equal to 2, and here the r is equal to 3, and here the r is equal to n was inserted. And we got a pattern that they are getting sliced like this, so we just cancel and we got our final two terms and got the answer. Now in the last part C, deduce the value of this. Now we have to write infinity instead of n. When we will write infinity instead of n, so what we will do, this is 3 upon 4 r plus 1 1 upon 4 r plus 1. Now we will write infinity instead of r. This is 1 upon 4, and if I write infinity here, it become minus 1 upon infinity plus 1, and this becomes 0. So if we multiply 1 upon 4 power infinity plus 1, this also becomes 0. I am not sure it becomes 0 or not, but if this becomes 0, it will make the another bracket all, so it will make the final answer 0. So that's why it will be equal to 1 upon 4 plus 0, which is equal to 1 upon 4. I hope you get our solution. As there is infinity, let me tell you again, as there is infinity, this complete becomes 0. Okay, this complete becomes 0. Let me tell you how. Infinity is a too large number. Too large number. If we write infinity plus 1, we can consider that it is 1 upon 1 lakh plus 1. If we calculate what is 1 lakh plus 1, we get, let me tell you, so we get 0.0000099, which is obviously like 0, because infinity is still larger than 1 lakh. It can be one more 0, it will again become 0.00. It can be one more 0, it can go along with the zeros, so it is equal to 0. I hope you get it. And infinity plus 1, if we add plus 1, there will be nothing change. It will still be too small value. If we do 1 upon infinity, the answer is too small. That's why we consider it 0. So that's why there is 1 upon 4 minus 0. So our final answer is 1 upon 4. I hope you get the answer. I hope you get the complete solution. Thank you for watching the video. We will be back with the next part while doing this fourth question. Thank you. Like and subscribe to the channel if you can.